What's up YouTube? Welcome back to Intuition. Today's video, we're going to be going over alcohol pharmacokinetics. So we're going to be answering 3 questions. Let's dive right into it. Question number 1. So question number 1 states, alcohol overdose can be deadly due to which fact? Okay, very straightforward question. So let's go ahead and look at the answer choices to see which one makes the most sense. Answer choice A says, alcohol undergoes zero order pharmacokinetics. Does that sound right? I definitely agree with this one. Why? Because zero order pharmacokinetics is pharmacokinetics where the rate of metabolism or the rate of elimination is constant. It does not vary with concentration. And that's really what makes alcohol deadly, because once you consume too much of it, it's very hard to eliminate it. The liver can only do so much. Once those liver enzymes become saturated, the rate of elimination remains constant. The liver is only able to metabolize a limited amount of alcohol at a time. Therefore, you end up having a buildup of alcohol in the body, which is going to cause toxicity. Just to make sure that we pick the right answer, let's look at answer choice B. B says, alcohol is a potent and toxic stimulant. Okay, right off the bat, this is wrong, right? Because alcohol is not a stimulant. Alcohol is a depressant, which confuses a lot of people because when people drink, they become less inhibited. What alcohol does is it depresses the inhibitory effects of the brain. So that's why alcohol is not a stimulant, it's a depressant. Okay? Answer choice C says, alcohol undergoes first order pharmacokinetics. That's incorrect. If alcohol underwent first order pharmacokinetics, it would not be as toxic as it is, because first order pharmacokinetics is when the elimination or the metabolic rate increases in proportion to concentration. The body would work faster to eliminate more alcohol within a given period of time. And finally, D says there is no treatment for alcohol overdose. Well, that's not true, right? There's definitely treatment guidelines to treat someone who comes in with alcohol overdose. Definitely giving them fluids. Dialysis will be another option for treating alcohol overdose. So there are different treatment options if this does occur. So D is definitely not the right answer. And the correct answer is answer choice A, zero order pharmacokinetics. All right? Okay, let's go on to question number 2. Okay, question number 2 states, zero order pharmacokinetics is also called saturable or Michaelis-Menten pharmacokinetics. The Michaelis-Menten kinetic equation is given by K equals Vmax times C divided by Km plus C, where Vmax is the maximum metabolic rate, Km is the concentration at which the metabolic rate is 1/2 of maximum, and C is the drug concentration. When does Michaelis-Menten kinetics behave like first order kinetics? So Michaelis-Menten kinetics is basically zero order pharmacokinetics. But if you look at the equation, there's some flexibility in that equation where there's a certain period or a certain range where the rate of elimination behaves like first order kinetics. Now, when you look at the Michaelis-Menten equation, it looks like it's directly proportional to the drug concentration, because in the numerator, there's Vmax times C, and Vmax is just a constant, that's just a number, and C is the concentration. So it looks like it's directly proportional to the concentration, but it's not, because there's also a concentration term in the denominator. So if we want this equation to be first order, we would need to get rid of the concentration term in the denominator. Under what condition can we eliminate the concentration in the denominator? In the denominator, we have Km plus C. If Km is a big number and C is a very small number, then we can basically pretend that C is 0 and just have the denominator be Km instead of Km plus C. And under those conditions, this equation would become first order. So the correct answer would be answer choice C, when the drug concentration is low. So when the concentration is low, we basically have first order kinetics, but as all the enzymes become occupied and saturated, then we get zero order kinetics. Okay? And that's how it works. All right, let's go on to question number 3. Question number 3 states, a college student chugs 5 cans of beer that each weighs 400 grams and has 5% ethanol. Assuming a 40-liter volume of distribution and an ethanol metabolic rate of 10 grams per hour, how long would it take for the student to be sober enough to drive? The legal limit is 80 milligrams per deciliter. Okay, we're dealing with alcohol, ethanol. We have someone who consumed a large amount of ethanol, and we want to know how long it would take before this person becomes sober. Well, the first thing we should do is take a look at the effect of consuming these 5 cans of beer. So when this student consumed 5 cans of beer, how much ethanol did the student consume? Well, let's figure that out. Each can of beer is 400 grams, so that's 400 times 5, and each of these grams consists of 5% ethanol, so we multiply by 5%, and when we multiply by 5%, we get 100 grams of ethanol. Now let's compare that to the legal limit. The legal limit is 80 milligrams per deciliter. But let's change that to grams per liters. When we change that to grams per liters, we get 0.8 grams per liters. And that is the legal concentration. If the legal concentration is 0.8 grams per liters, how many grams is this student allowed to have in his bloodstream? All we have to do is multiply by the volume of distribution, and we're told that the volume of distribution is 40 liters. So when we multiply 0.8 times 40, what do we get? We get 32 grams. So legally, this student can have 32 grams of ethanol in his bloodstream. However, drinking those 5 cans of beer led to him having 100 grams in his bloodstream. And now the question is, how long would it take to go from having 100 grams to having 32 grams in the bloodstream? We need to eliminate 100 minus 32 grams. And 100 minus 32 is equal to 68. 68 grams of ethanol need to be eliminated for him to get to the legal limit. And how long would it take for 68 grams of ethanol to be eliminated? We're told that the elimination rate is 10 grams per hour. So dividing 68 grams by 10 grams per hour, what do we get? We get 6.8 hours, which is approximately 7 hours. So it will take about 7 hours for the student to get to a legal limit of alcohol, for him to get sober. And the correct answer would be answer choice D, 7 hours. All right, easy. All right, so hopefully this video was helpful. These are basically more Naplex type questions or pharmacy type questions. Let me know if you have any questions about anything that we discussed today. Go ahead and subscribe if you're new to the channel. Welcome to Intuition. If you guys have any video requests about any other science topics that you want us to cover on this channel, go ahead and leave it in the comment. Go ahead and give the video a like and subscribe. All right, with that said, I'll see you guys next week. All right, bye-bye.